A triangle has many properties like the angle sum property, the exterior angle property, or some properties related to the isosceles triangles. But if you don't know how to prove those properties, or if you want to learn about those properties, then you've come to the right place, because this video shows you with visual proof and with animations why those properties of a triangle work. So without losing any more time, let's jump into the video straight away. Let's go. Hey guys, this is Vikas Sharma welcoming you on behalf of Exponent to Success to yet another video of ours. Exponent to Success is an initiative that helps to add an exponent to your learning curve. If you're new here, or if you're landing on our channel pages for the first time today, I would strongly recommend that you subscribe to our channel right now so that you do not miss out on any future content from us. And do not forget to click on the bell notification also, so that whenever any new content is uploaded, it comes right into your inbox. In our previous video, we learned about the congruence of triangles or congruent triangles, and we learned that there are 4 theorems which state that when two triangles are going to be congruent. And if you happen to miss that video by any chance, then the link to that video is on the top right corner of your screen. Just click on that link and you'll be taken to the video straight away. In this video, we are going to talk about properties of a triangle. There are various properties that a triangle has which are very helpful to know, such as the angle sum property, which states that all angles of a triangle must add up to 180 degrees, or there's the exterior angle property that if you take any exterior angle of the triangle, and if that should be equal to the sum of the opposite two angles. And then there are some properties related to isosceles triangles, like if two sides of a triangle are equal, or if two angles of a triangle are equal, then such kind of triangle is called an isosceles triangle. And the property of isosceles triangle says that if two sides of a triangle are equal, then the angles opposite to those sides are also going to be equal. And the converse of that is that if two angles of a triangle are equal, then the sides opposite to those angles are also going to be equal. So these properties are helpful to know, but how do we learn about these properties? How do we learn how to prove that? So just for you, I've got two isosceles triangles for you. So this is one of the triangles that we have. And the second triangle I'm going to take is a little different. I'm going to take it like this. So let me call this triangle as ABC. And let's say that this triangle is triangle PQR. Now the reason that I've taken two different triangles is because I wanted to prove two different ways how it can be proved. So let's say in this triangle it is given that these two sides are equal, and so is that in this triangle that these two sides are equal. And what we have to prove is that in this triangle we have to prove that angle B is equal to angle C, and in this triangle we have to prove that angle Q is the same as angle R. So let's learn two different ways of proving it. So in the first triangle, what I'm going to do is I'm going to drop a perpendicular to from the vertex A to the opposite side, which is the side BC. Now you know that if a perpendicular is dropped to the opposite side, then the angle that it makes with the side is a 90-degree angle. So in this case, this angle is going to be 90 degrees and this angle is going to be 90 degrees. Let's call this intersection point as M. So now we have two different triangles, which are triangle ABM and triangle ACM. Now let's learn how to prove that these two triangles are congruent, both triangle ABM and triangle ACM. So we know that both of these, triangle ABM and triangle ACM, they are right angle triangles because they have a 90-degree angle in them. So we know that angle AMB is equal to angle AMC is equal to 90 degrees because that was our construction, that we had dropped a perpendicular on the side BC. We know that AB is equal to AC, which is given, and we know that AM is equal to AM, which is a common side in both the triangles. So now we have a right angle. AB and AC are the hypotenuses in the two respective triangles, and AM is one of the legs in the triangle. So we can say that by Rhs congruence condition, or by the Rhs congruence theorem, we can say that triangle ABM is congruent to triangle ACM. Now let's prove it the other way also. So because I don't need this, let me remove this. So in the other triangle, we are going to do things a little differently. What we are going to do is we are not going to drop a perpendicular now. We are going to take a angle bisector of angle QPR. So angle QPR, we are going to bisect that angle. So when we draw a angle bisector, let's say that this is the angle bisector that we have. Now let's call this side whatever you may call it. Let's take M only. So we have got two triangles which are triangle PQM and triangle PRM. So now since PM is the line which is bisecting the angle P, we can say that angle QPM, which is this angle, and angle RPM, which means this angle, they are going to be equal. We have that angle QPM is equal to angle RPM. We don't know the measure of that angle because that we know by construction that those two are going to be equal because the line PM was an angle bisector of the angle Q. We also know that PQ is equal to PR because that's been given to us that these two sides are equal. And we have PM in both the side triangles, which is a common side. So we can say that PM is equal to PM, which is a common side. Now let's see what we have. So we have an angle here, one of the sides and one of the sides. So this side and this angle is the included angle. So we can say that by the Sas congruency rule, we can say that triangle PQM is congruent to triangle PRM. And where here we had that triangle ABM is congruent to triangle ACM. Now if this is the case, then we know that all those 6 things in both the triangles are going to be equal that we discussed in the last video in the congruence of triangles. So by CPCT, we can say CPCT means congruent parts of congruent triangles. So we can say that angle B is equal to angle C, which means that this angle, let me take a different color here, which means that this angle is equal to this angle. Which means that if two sides of a triangle are equal, then the angles opposite to those sides, which means this angle, and to opposite to this is this angle, they are going both going to be equal. And here again by CPCT, we can say that angle Q is equal to angle R because they are corresponding parts of congruent triangles. So again we can say that angle Q is going to be the same as angle R because we had two equal sides PQ and PR. So angle R is the side opposite to PQ and angle Q is the side opposite to PR. So if you want to know about the theorem, what that theorem says, then the theorem is this. And the theorem says that angles opposite to equal sides of an isosceles triangle are equal. Now let's come to the converse of this theorem, and the converse says that if two angles of a triangle are equal, then the sides opposite to those angles are also going to be equal. So let us again prove it in two different ways. So let me take two different isosceles triangles, and we know that they are isosceles because we have been given that in both triangles this angle is equal to this angle and this angle is equal to this angle. Let me name the triangle. So let me call this triangle DEF and let me call this triangle XYZ. In the first triangle, I'm going to drop a perpendicular from side D to the opposite side, which is EF. And because it is a perpendicular, we can say that this angle is equal to 90 degrees and this angle is going to be 90 degrees. Now let's see what congruence condition is going to work. This is the RHS is not going to work here because in RHS it stands for right, hypotenuse and side. So we know that one of the sides is equal in both the triangles, which is the side DA. Let's call this A. So DA is equal or common in both the triangles, so that obviously is equal. But the hypotenuse DE and DF are not equal. That is what we are going to prove, that they are equal. Now, if they are going to be equal, what we know is that this angle is equal to this angle. So we have got two angles of triangles are equal and one of the sides is equal. So what congruence rule is going to apply here? Yes, you guessed it right. It is the Aas congruence rule or the Saa congruence rule, whatever way you want to call it. So therefore, by Aas congruency or Saa congruency, we can say that triangle DEA is going to be congruent to triangle DFA. And if they are going to be congruent, then we can easily say that DE is equal to DF, because by CPCT or by corresponding parts of congruent triangles, they are going to be equal. Now, another thing that is important in isosceles triangle is that when we drop a perpendicular, then the base, which is EF, that also is divided into two equal parts. So this is the proof for that as well, that this side is going to be the same as this side in both the triangles, because both triangles are going to be congruent. So it is the same proof that works for proving that also. So in this triangle, we are not going to drop a perpendicular, we are going to draw an angle bisector which divides angle X into two equal parts. So because it divides angle X in two equal parts, we can say that this angle is equal to this angle. So both these angles are going to be equal. Now we don't know that these are 90 degrees or not. We cannot say that. All we know is that angle Y is equal to angle Z. Let this intersection point be W. All we know that angle Y is equal to angle Z, and that angle YXW is the same as angle ZXW, because XW is the angle bisector of angle X. So one angle is equal, the second angle is equal, and this side that we have, this is a common side in both the triangles. So this is going to be equal. So if that is going to be equal, then we can say that triangle XYW is congruent to triangle XZW. And if that is the case, we can say that XY is equal to XZ. Again, by CPCT or corresponding parts of congruent triangles, they are going to be equal. And again, like in the previous example, the proof is the same for proving this also, that an angle bisector in an isosceles triangle will divide the opposite side in equal parts. So we can say that YW is also equal to WZ. Now let's come to proving the other two properties, that the angle sum property and the exterior angle property of triangles. So for that, I have created a very simple visual for you. So let's jump to the visual straight away. So here we have a triangle ABC, which has got three angles, 65.5 degrees, 59.5 degrees and 55 degrees. And if you see on the top, the sum of all angles, I've added the three angles together, and that sum is equal to 180 degrees. Now here in this triangle, these three angles add up to 180 degrees, and why they add up to 180 degrees is because if we rotate in a different way, in a different manner, just keep looking at angle B here, what happens to angle B, and if I rotate this triangle, angle B is going to go right next to angle A. And similarly, I'm going to rotate this triangle one more time, but in the other direction. So keep looking at angle C here, which is 55 degrees. So I just rotate it and look where angle C is going, and it lines up right next to angle A. So as you see, all three angles of a triangle, I have lined them up together and they are on a straight line, and because they are on a straight line, they should add up to 180 degrees. So that's a real nice visual proof of how we can do that. But what about if we change the triangle a bit? Will it still add up to 180 degrees? Will they still make a straight line? Let's see. Let's change the triangle here. Let's move this triangle this way. Now you say that the angles have changed. They are 105 degrees, 41.9 degrees and 33.1 degrees, and the sum remains the same, which is 180 degrees. Does this proof now work? What if we line these angles together? Look at angle B. When I rotate it, it lines up with angle A, and here again I rotate it in a different way. Angle C lines up with angle A, and again they all lie in the same straight line, so that is going to be equal to 180 degrees. Let's take another triangle, but in a different way. Let's bring this here. I can do it whatever way I like. I can take this here, this kind of triangle. Here the three angles are 16.4 degrees, 129.7 degrees and 33.8 degrees. If I add them all together, it's still 180 degrees. If I move the slider, this triangle goes here and this goes here. So again they lie in the same straight line, which is 180 degrees. So no matter what triangle I take, let me take a triangle like this. Even if I take a very small angle like this also form a triangle where one angle is 4.2 degrees, one angle is 5.1 degrees, and one angle is 170.7 degrees. If I again rotate it, see how it lines up with angle A, and I rotate it here. This again lines up with angle A, though it's not very clearly visible. But if I do it like this, so whatever way you rotate the triangle, see that straight line is never changing. That is always going to be a straight line. And because the three angles are lined up perfectly, therefore the sum of all angles of a triangle must add up to 180 degrees. Now, without 180 degrees, a triangle is not even possible. So even if you want to try it, take two obtuse angles, those lines are never going to meet each other and it will not form a triangle. So you can't make a triangle unless all angles add up to 180 degrees. Now let's look at one more property of triangles, which is the exterior angle property. And the exterior angle property says that if we have one angle, an exterior angle, it is going to add up to the sum of the two opposite angles. So if we are talking about this angle here, this exterior angle, the two opposite angles are this and this. So if you add these two angles together, the sum is going to be the same as this. So angle A and angle B basically should be equal to the exterior angle C. So angle A is angle B is 52.95 degrees, angle C is 72.43 degrees, and if I add them together, it comes to 125.53 degrees, which is this. So let's rotate these triangles and see what we get. Don't bother about the lines there. That was just to show. What I'm trying to show is that the angles have changed. Now we have 91.69 and 52.22, and if you add them together, you still get a sum of 144.07, which is the same as the exterior angle. The exterior angle keeps changing. So in a triangle like this, the exterior angle is now 70.93, and so have the opposite angles also changed. But if you still add 24.43 to 46.34, they're still going to add up to the exterior angle. So you take any triangle, the sum is always going to be the same. You take a triangle like this, it is still going to be the same. You take a triangle like this, it is still going to be the same. Whatever way you take the triangle like this, a very tall triangle, it is still going to be the same. So that brings us to an end of the video. I hope you enjoyed the video thoroughly and you learned something useful out of it. In case you did, I would like to hear all about it. So just head down to the comment section below and leave in your comments for me. In case you are facing any problems with any of your questions, or in case you want me to cover any specific topic, just mention that in the comment section too, and I'll surely get back to you with a video. I would surely recommend that you hit on the like button below and share the video link with your friends so that they also learn something useful out of it. And in case you haven't subscribed to our channel as yet, this is the right time to do so. You see a subscribe button right in the center of the screen. Just click on that and you'll be subscribed to our channel straight away. And do not forget to click on the bell notification also so that any future content is delivered right into your inbox. As a part of your continued learning, you can click on these videos shown on the left side here. Please like and share the video. Take care. God bless.